Hello everyone, welcome to Physics Blender e-learning platform. I am teacher Huda Laraqi. Today we are discussing some important and some challenging questions about motion. Let's start. We have classwork paper 1. We have 32 questions. You can find all questions, all documents, all mark scheme if you join our Telegram channel Physics Blender. You can find the link in the description. Okay, let's start. As usual, we have the KWL chart. You can write down here what you know about motion. You know some expressions like speeding up, slowing down, acceleration, deceleration, and so on. What you want to know about motion, maybe you would like to know what is the relation between motion and sports, why motion is important in our daily life, and so on. At the end, you can write down here what you learned. Let's start by question number 1. Question number 1 is a challenging question. There is a common mistake here. Let's read the question first. A runner runs 300 meters at an average speed 3 meters per second. We have two sections. Okay, during the second section of the race, she runs another 300 meters at an average speed 6 meters per second. Okay, so here the speed is not constant. What is her average speed for the total distance, okay, during the race? Okay, the common mistake here, students, they add V1 plus V2 and divide the answer by 2. So 3 plus 6 divided by 2 is 4.5 meters per second, and you will find this answer one of the choices. Okay, but this answer is incorrect. Okay, you have to use the word equation. Average speed is equal to total distance traveled divided by total time taken. You have the total distance traveled already, which is 600 meters. And it's very important to check you are working in consistent units. Okay, total time taken, you have to find the value of total time taken. I can get the value of time during the first section first, 300 meters, 3 meters per second. I can use these values to get T1. So T1 is equal to 300 divided by 3, and check you have consistent units. The answer is 100 seconds. What about the second section of the race? 300 meters, 6 meters per second. So T2 is equal to 300 meters divided by 6 meters per second. You can get your answer is 50 seconds. Total time taken is 100 plus 50. Your final answer will be 600 divided by 150, which is 4 meters per second. So far so good. So your answer is B. Question 2. A girl goes for a ride on her bicycle. The diagram showing how her speed changes with time for part of her journey. In which labeled section the girl is moving at a constant speed. First of all, you should know that graph tells a story. Some features of the graph can tell you details about the story. You have to look at the y-axis first, the label of the y-axis. If the y-axis is labeled speed, it means the gradient here in this case is equal to acceleration. The question is asking you about constant speed. Constant speed, it means speed is not changing. Speed is not changing, which means zero acceleration. Zero acceleration means gradient should be equal also to 0. Which section the gradient here is equal to 0? It means the straight line is horizontal and parallel to the x-axis. Which part? You have section, this section labeled A, and this section, but this section is not labeled. So which labeled section? The correct answer is A. Can you tell me which section the girl is not moving at all? The girl is not moving at all, which means velocity or speed here is equal to 0. Let me know in the comments. Question 3, we have a car is moving along a straight level road with a constant acceleration. So here we have acceleration, which means the speed is changing. So when we compare the choices we have in our question, you have to look at the y-axis, the label on the y-axis. So distance time graph, you have a horizontal line parallel to the x-axis. It means in this case speed is 0, which means no acceleration at all and no speed at all. So here speed is equal to 0, which means a stationary object. What about B? So we have to exclude A. What about B? It's a distance time graph, but it's not a curve. We have a straight line passing through the origin, which means the speed here is constant speed. The speed is not changing. So also we have to exclude B. Now we have to choose between C and D. We have a speed time graph here in C. Gradient is equal to acceleration, but in this case we have a straight line horizontal to the x-axis, which means 0 gradient. The gradient here is equal to 0. Gradient is equal to 0, which means acceleration is 0 also, which means speed is not changing. Speed is constant speed. So also this one is excluded. What about D? We have a straight line and the gradient here is equal to constant acceleration. So we have uniform or constant acceleration, which means the gradient is equal to the acceleration. Okay? And we have here a straight line, which means uniform acceleration or constant acceleration. You know how to calculate acceleration. You have to calculate the gradient change in speed divided by change in time. So acceleration will be equal to delta V divided by delta T will give you the gradient or the value of acceleration. Question 4. The diagram is speed time graph for a bicycle journey. When is the bicycle moving at a constant speed? Graph tells a story. You have to look at the y-axis first. It's labeled speed. So the gradient is equal to acceleration. The question is asking you about which section or during which time interval the bicycle is moving at a constant speed, means zero acceleration, means zero gradient. Means the section where the straight line is parallel and horizontal line parallel to the x-axis. Which one here is the horizontal line parallel to the x-axis? Between 20 seconds and 40 seconds. The correct answer is, B, between 20 and 40 seconds. Question 5, we have diagram showing speed time graph for an object moving at constant speed. What is the distance traveled by the object during the first 3 seconds? Use the equation. The area under the graph is equal to distance traveled. So if you calculate this shaded area under the graph, you can calculate the distance traveled. Okay. Why we are doing this? Because we have here this dimension is representing time and this dimension is representing speed. Okay, distance is equal to time times speed. So if you calculate the area of this rectangle, will give you the value, the numerical value of distance. But this equation, you can use it if you have constant speed only. If you have speed time graph and the speed is changing, now we have acceleration, constant acceleration. In this case, if you calculate the area under the graph, you have to calculate half times base times height. Base here representing time, height here representing speed. Since the speed is changing, as if we are calculating the average speed. So this half now in the equation is represented so as if we are calculating average speed, because we do not have here constant speed. Okay, later on we will discuss this in some questions. Back to our question, the area under the graph, so it will be easy to calculate the distance traveled. We have 3 times 2, 3 times 2, check you have consistent units, so the answer is 6 meters. The correct answer is D. Question 6 is a challenging question. We have diagrams, distance time graphs for 4 bodies. Which body is moving with increasing speed? Increasing speed. Increasing speed, it means acceleration. It means speed is changing. Okay? So we have to exclude A, because here A, it's a description for a body which is moving at constant speed. The acceleration here is 0. Constant speed, 0 acceleration. So this one will be excluded. B, it's a stationary object. The body is stationary. Speed is equal to 0, so not changing. We have to choose between C and D. It's a challenging question because we have a curve The graph here, it's a curve. And the description here is we have non-uniform acceleration. The acceleration here, it's not uniform. The speed is changing, but the speed is not changing uniformly or at a constant rate. How can we compare if the speed is increasing or decreasing? You have to compare the gradient, which is the gradient of the tangent. The gradient of the tangent indicates the speed. We have an important concept here. The gradient of the tangent indicates the speed. So if you compare between C and D, which tangent is steeper? The steeper one is D. So the correct answer is D.
Subscribe for more videos. I love Physics Blender. I love Physics Blender. I love Physics Blender. I love Physics Blender. I love Physics Blender.